Hi, I'm Andrea and welcome to Productive C#. In this video, I'm going to talk about actions, functions, and Lambda expressions in C#. Here, I have some code that I've taken from a previous video where I've described what delegates are in C#. As you can see, we are defining two custom delegates, display and operation. Display is a delegate that takes an integer and return nothing. An operation is a delegate that takes two integers and return a value. And the way these two delegates are used are in the calculate function that is taking the display and the operation, asking for two numbers from the console, calling the operation, getting the result, and then using the display delegate to actually print it on the screen. Now, in C#3, Microsoft introduced actions and functions that are effectively delegates that are already available inside the .NET framework. This means that when you need to create a function that uses delegates, you don't need to create your own delegates every single time. You can just use actions and functions directly. So let me use them in this code. Actions are delegates that returns no values. So for display, we're gonna need to use an action. So I replace display here with action, and the action is defined as a generic types that takes 1, 2, 3, up to 16 parameters. In this case, we want only just an integer as parameter, so we just use integer as type. So now display is of type action int. This means that we can remove display as a custom delegate, and I can use action integer as a type of my display local variable. And then let's do operation. Operation is returning a value, so we need to use func in C#. Func takes the type of the parameters, in our case two integers types, and at the end the type of the result that you want. You can take up to 16 parameters and return a type. In our case, we still return an integers, right? Now we can get rid of operation, and we can use func int as a type for our operation local variable here. Now this code is effectively working as before, but we don't have anymore the two custom delegates, and we are using the built-in action and func in C#. If you go to the .NET/runtime project in GitHub, where effectively the .NET Core source code is defined, you can have a look at the action.cs class and to see exactly how the action delegates has been defined. And you can imagine these are just normal delegates that takes up to 16 parameters. The same for func. You can find them in function.cs, and you can see there are effectively a lot of func that takes up to 16 parameters and return a type. Okay, so these func and actions are built-in delegates that you can use in your code so that you can avoid creating custom delegates yourself. There's one downside of using this, that is you obviously lose a bit of readability. In the previous code, we were using display and operation directly as the name of our type. In this case, our type becomes func int. They might not be the most readable type, but it's very common practice to use action and functions in C#, and the more you get used to it, the more it will be familiar with you. However, there is still space for you to create custom delegates in case you want to increase the expressiveness of your code, and you want to make it, your delegate a first-class citizen in your library or in the code you are currently developing. The next step I want to show you, however, is how to use Lambda expressions to pass delegates to functions. In this code, as you can see, print is the name of the method print that actually print the result. Instead of using a method, I want to use a Lambda expression to define the display variable. What I can do is I use this syntax here, type int n equals greeter, and then I provide the code inside the method. Let me copy this line here, and I put it here. Now I can remove this method. So what I've done is I created effectively an anonymous method here. Instead of creating a separate method inside a class, I define the body of my delegate using a Lambda expression. The syntax is fairly obvious. You take a list of parameters with their type, and then the body of the function. But the advantage is that you don't need to define a name for this particular method. You can do the same for the func. Instead of passing a method, I can use a lambda here, int a, int b, and I return a by b. And I can remove this method. This is very common in C#. When you pass a method to a function that takes delegates, often you don't create separate methods to pass them around, but you use Lambda expressions as a very nice shortcut to actually define the methods themselves. The good things about the C# compiler is that often you can make this syntax very compact, and I'm going to show you now how you can do that. First of all, the compiler, let's start with the action, is automatically able to infer the type of your parameters most of the time. So you can just remove the type here. Then, if you have an action that only takes one parameter, you can remove the brackets as well. And finally, if you have an expression body here, that is, if you have a body here, a statement body here that only contains a single line, you can convert this one into an expression body. That means you don't need to put the parentheses, you can just do that in a single line. So now this one is a Lambda expression that define effectively the method, the anonymous method that will be assigned to your action delegate. You can do the same for a function. You don't need to specify the types for A and B. And because there is only a single return statement, you don't even need to use return word. You can remove the brackets, remove the return, and just do this super short Lambda expression. So now operation is a delegate, a func delegate. It's pointing to an anonymous method defined using this Lambda expression that is A by B. You can do even a step further, because as you can see now we're using action int and func int in here. Most of the time you can easily inline the code directly. So I can just do Ctrl RI using resharper and go to this operation, Ctrl RI in here, and now I'm calling the calculate method, passing the Lambda expression for the print, for the display, and a Lambda expression for the operation, without even showing action and functions, directly in the code. Okay, so the methods that takes, action and function, it might still be a bit harder to read, but when you start using the code, often action and function are completely hidden by the compiler, because the compiler automatically convert this Lambda expression into anonymous method that can be assigned to delegates. So I understand there is a lot of concepts in this video. First of all, make sure you understand the concept of delegates, how delegates work in C#. You can see my specific video on delegates. As soon as you understand delegates, you can understand now that there is an action and func delegates that are already defined for you by .NET. And then, instead of defining methods yourself, you can use Lambda expressions to create a very compact anonymous method directly at the point when you need it, without having to define a method, without having to provide a name and stuff like that. These features combined are the foundation of LINQ, language integrated query. In fact, all the language integrated query functionalities has been implemented using extension methods that takes functions as arguments. I can show you this very quickly. For example, if I have an array of numbers, I can do numbers.where to filter this list of numbers, and what the where method accepts, as you can see, is a func int bool. So it's a func that takes the type of the array, in this case integer, and return a boolean, meaning that if you want to keep the number or not, so if you want to filter it out or not. For example, if I do x greater than 2, I'm telling to the where function that I only want to consider the numbers greater than 2. And as you can see, I can use lambda expressions to provide a very short and compact declarative way to express a predicate for this where operation. And this is effectively what I wanted to show you today. So in the modern C#, starting from C# 3, you don't need to define custom delegates anymore. You can use the built-in action and function defined in .NET, and pretty much all the time you're going to use lambda expressions to define those anonymous methods that you want to pass to functions that take actions and functions. Thank you very much for listening.